Golden things are all the rage these days.
Like golden jewelry.
Golden hour.
The song Golden by Harry Styles. But one golden phenomenon has withstood the test of time, and that's the golden ratio.
It's found in a lot of different shapes, but the easiest way to see it is in a golden rectangle. A golden rectangle's dimensions are specific. If a square is removed with the dimensions a times a, what's left is a rectangle with side lengths b times a. If rotated, this rectangle is proportional to the original.
Using the proportions, we can write the ratio a plus b over a is equal to a over b, which is equal to phi, the sign for the golden ratio.
Let's find a numeric value for the golden ratio.
Let's start with the equation a plus b over a is equal to phi. The left side can be split into a over a plus b over a. A over b is equal to phi, therefore the reciprocal b over a is equal to 1 over phi, all equal to the golden ratio. At this point, if we arithmetically solve for phi, our golden ratio value is 1 plus the square root of 5 over 2.
A cool thing about the golden ratio is its relation to another famous set of numbers, the Fibonacci sequence, which is where a term is equal to the sum of the previous two terms.
Starting with 1 and 1, we add those together to get 2, and then follow this pattern to get the Fibonacci sequence, which goes 1, 1, 2, 3, 5, 8, and on and on. Now let's look at these terms as ratios, with the numerator being one term and the denominator being the previous term. If we continue this pattern infinitely, it appears the numbers are approaching the golden ratio, but let's prove it for ourselves. Let's rewrite these. 1 over 1 can be written as 1, 2 over 1 can be written as 1 plus 1 over 1, 3 over 2 can be written as 1 plus 1 over 1 plus 1 over 1.
That's a lot of ones. Don't worry, it gets better.
Let's assume that this pattern for writing the Fibonacci ratios extends infinitely. We can set this part equal to x. Because the sequence is infinite, the denominator is also equal to x. This can all be rewritten as 1 plus 1 over x equals x. Look familiar? If solved, x equals 1 plus the square root of 5 over 2, our golden ratio.
This can be represented visually too.
If we put squares together with dimensions of the Fibonacci sequence, they form a golden rectangle. Within this Fibonacci rectangle, a spiral can be formed.
That figure is how the golden ratio relates to real life. Golden ratios are visually pleasing and are subsequently used in architecture and art.
The Greeks understood the golden ratio when building the Parthenon. Da Vinci painted the Mona Lisa using the Fibonacci spiral. And the golden ratio is a key tool of graphic design.
But the coolest thing about this number is its presence in nature.
From flowers, to shells, to even hurricanes.
This number is so intricately woven into our lives, yet it can be reduced to a simple sequence. Pretty cool, right?